Hi everybody, John Carney, Product Engineer at Cadence, and this video I'm going to walk you through how to use the integrated impedance analysis feature to find and fix impedance problems in your design. To access the integrated analysis features, you can go into the View menu under Panels and choose Analysis Workflows. That's going to open up this additional panel, which you can dock to anywhere you want in the user interface or on a second monitor and you have it. And these workflows are designed to allow you to just kind of work your way from top to bottom through picking the type of analysis you want. For example, in this case, we'll select impedance, setting up the analysis through setting up different preferences or type of analysis you want, running the analysis, and then viewing the analysis results. Impedance analysis is the easiest to set up and run. The first thing you want to do is determine which nets you want to analyze in the design, and you can do this by a net-based selection or a directed group selection. A net-based selection is just like it sounds. You effectively are given a list of all the nets in the design. You can choose flat or hierarchical. Hierarchical is going to give you the list of nets, potential nets to analyze based upon context in terms of diff pairs, X nets, and buses. So if you want to, for example, analyze an entire bus, you can select that and you'll push it over to this right-hand side, which means that is selected for analysis. Or if you just want to go flat, then it's just going to give you an alphabetized list of all the nets in your design. So through this selection mechanism, you can pick the nets or buses or interfaces that you want to analyze. The reason you may not want to analyze every net in your design is because you may not care about the impedance for every net in your design. And also, the less nets you select to analyze, the faster the analysis is going to run. Now, for a design this size, the analysis is still going to take maybe under 2 minutes, so it's not really that big of a deal. But considering this workflow allows you to run analysis, find problems, fix problems, and rerun an analysis, spending a little bit of time optimizing that analysis run will allow you to get to a finished result faster. If you want, you can go into the analysis options, and this is where you have a couple of options for the simulator, whether or not you want to model coplanar traces, what kind of electrical models you want to use, what field domain you want to use, net and shape options, and different type of layout options for cutting parameters. For impedance analysis, you probably don't need to go into this very much, but for some more of the advanced analysis capabilities, like a thermal workflow or a reflection workflow or a crosstalk workflow, you may want to dive in here a little bit. This next option allows you to set up a cutting around the nets that you have selected for analysis. Effectively, what this analysis is going to do is it's going to throw the whole circuit that you're analyzing into a field solver that needs to mesh and simulate it. If you can cut out the area around the net you're analyzing, it'll also allow the field solver to run a lot faster. If you're doing an impedance analysis, this probably isn't necessary, but if you're doing some sort of full wave 3D analysis, cutting only around the nets that you're interested in will certainly speed up your analysis results. Once you get everything set up to run the analysis, you can then just hit the Start Analysis and it'll run the analysis engine for you. If you've spent a lot of time setting up this workflow, you can even save these workflow settings and recall them again at a later time or even on future designs if you'd like. Once the analysis is complete, you get the results presented to you in a lot of different ways. Firstly, and most notably, once the analysis is run, over here you can choose to view impedance visions, and then it's going to overlay on the design canvas colors representing the different impedance values measured during the analysis. So you get this range over here. That does not mean that red is bad and blue is good. It's just red is the highest value it found, blue is the lowest value it found. And you can kind of see by zooming and panning in around here that you do have different impedance values in the design. If you want to make it easier to see, you can use this slide bar here to really only focus and highlight on an explicit range of impedance values that you want to look at in the design canvas. You can also go to the visibility controls that you use during normal layout and use that to selectively turn on or off different layers in the design. So if you want to navigate these impedance values based upon different layers, you can do that as well. Over in the analysis workflow panel, you can also change it from single-ended to diff pair. That's going to then show you, instead of single-ended impedance, differential impedance, and this heads-up display marker here adjusts to show the range of differential impedance values. So you can now use that, and for example, you could scroll in and just very easily visually see that you have a lot of differential pairs that are around the 88 to 100 ohm impedance value differential. So since this is integrated into the layout editor, if you wanted to change these impedance values or manipulate your design, you can easily do so. You can keep the impedance visions on, or you can turn them back off to go into the regular layout view, whichever you prefer. And then once you are in the view that you like, you then have full access to all the command editing tools. So you can go into Add Connect, reroute differential pairs. You can go to Slide differential pairs. You can change differential pairs to different layers. The whole advantage of having an integrated analysis and layout solution like this is you've run the analysis, you can then change the design, and then you can just rerun the analysis immediately and see if the change you made affected the impedance goals or analysis goals in a positive way or a negative way. So this really allows you to find and fix issues very quickly. In addition to the graphical overlay, you can also select this option here to view impedance tables. This is going to give you a very detailed chart showing you a lot of information. I've chosen to dock it on the right-hand side of my screen. You can also dock it on the bottom side of your screen, or you can dock it to a second monitor if you have that. So what this chart gives you, I'm just going to pull it out and make it a little bigger so you can see the depth of the data that's in here. So it gives you two different tabs, single-ended and differential pair. For both of them, it's going to give you a list of all the nets in the design, the number of vias per net, the number of references that net has, its max, min, typical impedance, the impedance length at the max, min, and typical, the total length, and then the resistance, inductance, and capacitance. You can look at that for single-ended and also differential pairs. That's very useful. You can then use this to kind of sort on different values in the design. So let's say you wanted to find where is the maximum differential impedance in the design. So I've gone to differential impedance. You can select the column header, and now you can see that this particular diff pair has this maximum impedance value of 112. If you select one of those nets from the diff pair or single-ended table, it's then going to populate the bottom half of the table with all the individual segments that that net or diff pair has. So now you're really diving deep into the problem. You can see that this net at some point has an impedance of 112. And now you want to find out, well, where is that? So that particular net has several different segments that have different impedance values. Some have an impedance value of 27, some have an impedance value of all the way at 100. You can see that that's on the bottom layer. If you want to find out where that exactly is at, you can double click on any one of those segments. And now let me redock this over here to get that out of the way. So clicking on any one of these segments is going to take you to that segment in the design. So now you really know, I found this segment of this differential pair that has this high impedance value. It's really short, but is that going to negatively affect my signal? If you know right out of the gate that this is not good, you can start rerouting and reworking this differential pair. If you want to determine, well, what is that going to do to my signal? You can then use another workflow like crosstalk, reflection. They can start sending impulses down these transmission lines, and then you can measure it. So you have a lot of different types of analysis at your capability, at your disposal. Some people just rule of thumb, no, oh, I'm just going to reroute this differential pair and slide around and find and fix it that way. So this has been just kind of a quick introduction to the impedance analysis workflow inside the OrCAD X layout editor. I hope this was helpful. Thanks for watching.